Hello guys, hello friends, welcome back to our normal revision for the Mathematics 2023 Paper 1. We are done with the Mathematics section 1 and today we are going to start section 2 of the paper. So in section 2, you are always asked to answer only 5 questions, and it is very strict, whether put it in bold, 5 questions in this section. They are going to provide you with 8 questions. You're supposed to answer 5 questions. In each question carries 10 marks. So under this question 17, the first one, you are asked that two towns A and B are 400 kilometers apart. As you can see, I've just started here in a sketch. A motorcyclist traveling at an average speed of 60 kilometers per hour left town A for town B at 1:20 p.m. A matatu traveling at an average speed of 80 kilometers also left town A for town B at 2 p.m. So we have a cyclist and we have a matatu. I've just written there the general summary. You are asked the first question. You calculate the distance covered by the motorcyclist by 2 p.m. So this is linear motion in form 2. Let us hear the way it goes. Now, if the motorcyclist started his journey at 1:20 and the matatu, you are asked, we want to see the distance covered by 2. So let us see first, what is the time? Time between 2 p.m. and 1 p.m., 1:20 p.m. is what? I'm not going to convert them into 24 hours o'clock because they are both p.m.s. Therefore, if I subtract here, I'm just going to borrow here 1 hour to bring here to be 60. So we have 40 minutes. Yes, and I also have the speed of the motorcyclist. The speed is 60 kilometers per hour. So it means I can find the distance. If the conversions are in hours, then I also have to convert this one to hours. So the time is going to be, time will therefore be 40 over 60. That one is in hours. Or you can say 2/3. Therefore, distance, distance is equal to speed times time. So I'm going to take 60 times 40 over 60. This one and this will cancel. Therefore, by 2 p.m., the motorcyclist had covered 40 kilometers. Part B, distance from point A in kilometers where the matatu caught up with the motorist. Now here is where most of the students get confused. I want us to be very accurate here. We are going to look first, what is the already distance covered by the motorist before the matatu started? The distance, we know that it is 40 kilometers. So I can write here, distance covered, it is 40 kilometers. Can I get the relative speed? Yes, I can get relative speed of two bodies that are moving towards the same direction. What do? We subtract. Therefore, I'm going to take 80 kilometers. I subtract by 60. That is 20 kilometers per hour. Then we are going to proceed, because what they want is the distance from A in kilometer. So let us go back to the distance already covered by the motorist, the motorcyclist. Distance covered already, time taken already was 40 kilometers. Therefore, I have distance and I have speed. So what is left here? It is time. Therefore, time is equals to distance over speed So that is 40 over 20. So the time that is going to take the matatu to catch up with the motorcyclist, it is 2 hours. But have we been asked that? No. From here, I can go into any of the two ways. Either use the matatu or use the motorcyclist. So if I start with, if I want, for example, to use the motorist, what will I say? I'll say that distance is equals to speed times time. That one if I want to use the matatu. So the speed for the matatu I've given as 80 times the time taken for them to meet is 2 hours. Therefore it is 160 kilometers as the distance from point A. Or I can still use the motorcyclist, and I say that this person had already covered 40 kilometers. Then I add to the speed, the same way I've used here, speed times the time. If you do that one, you also get 160 kilometers. Any of this should award you the mark, either using matatu or using the motorcyclist. The next question, part 3, Roman 3 of that. Time when the matatu caught up with the motorist. Now we know very well that they met after 2 hours. So if they met after 2 hours, therefore, if the time at which the matatu started the journey was 2 p.m. and the time taken for them to meet is after 2 hours, therefore this one is now going to be 4:00 p.m. or other people will say 16:00 hours. They are not specific. Any, this one and this one are both right. Then part B, a lorry traveling at an average speed of 40 km left town B for A at 2 p.m. Determine the time when the lorry and the matatu met. Now, if I don't want to go back at the top, let me just draw another one here. We have point A, point B. We know that the matatu traveling at a speed of 80 kilometers per hour. This time we have a lorry coming from this side. The lorry is moving this way, this one is moving this way. The distance is 400 kilometers. The speed, it is 40 kilometers per hour. Therefore, because the time are the same, they both started at 2:00 p.m. So this rather more simple. You're not going to find any difference. The distance in which they are competing for is called the relative distance. So relative distance becomes 400 kilometers. Then relative speed for the bodies that are approaching each other, we are going to add, contrary to the way we did for the bodies that are going on the same direction. So here we are going to have the speed, which is 80 plus 40. So speed, here we have 120 kilometers per hour. Then what is next? I have relative distance, relative speed. I don't have time in which they met. So time is equals to distance over speed. Therefore 400 divided by 120. So 400 divided by 120, I get that, but I'm going to press this function here. So it means it is after 3 hours. It took 3 hours, 20 minutes. But the question is asking the time when the lorry met, the exact time when they met. So I'm going to take the time taken for them to meet plus the time which they started. So I'm just going to add here 2 hours, 2:00. Therefore, these people met at 5:20 p.m. Thank you very much.